Welcome to Klein's Calculus. Today we're going to look at lesson 3-5, examples 4 and 5. We're going to start by finding equations for lines tangent and normal to the graph of y equals 4 plus cotangent of x minus 2 cosecant of x at x equals pi over 2. Well, we know when we're looking for equations of tangent lines that we need a point and a slope. Also, for normal lines, we need a point and a slope. So the first thing we'll do is we'll guess the point. And we'll do that by putting pi over 2 into this function and just evaluating it. We can do that quite easily without a calculator, because if you put this in, you've got 4 plus the cotangent of pi over 2 minus 2 times the cosecant of pi over 2. Well, I know on my unit circle, pi over 2 is at the point 0, 1. And the cosine is the x-coordinate, and the sine is the y-coordinate. So since I can write the cotangent in terms of the sine and cosine, and I can write cosecant in terms of the sine and cosine, this is an easy thing to evaluate. So I'm going to write cotangent as the cosine over the sine, and cosecant as 1 over the sine of pi over 2. Now, this becomes real easy because the cosine is 0 and the sine is 1. So here I just have 0 over 1, or 0. And I have 2 times, I have 1 over the sine of pi over 2, so 1 over 1, so 2 times 1. So this evaluates to 4 minus 2, which is 2. So I have a point on this function, pi over 2, 2. I'm halfway to finding my line. Now I need to find the slope. To find the slope, I need to take the derivative of this function. And to do that, I'm just going to remember what I learned in the previous section about my cosecant. The derivative of the cotangent is the negative cosecant squared, and the derivative of the cosecant is the negative cotangent of x, cosecant of x. Well, since this was minus here, I have minus and a negative, so I'll make that positive. And now I have a nice trig function that I can evaluate. Since I want the slope at pi over 2, I need to plug in pi over 2 to this function. So again, I'll write cosecant as 1 over the sine, and it's the sine squared, so I'll just find the sine of pi over 2 and square it. And cotangent is the cosine over the sine, and cosecant is 1 over the sine. So again, I'm thinking about this point 0, 1, x, y, cosine, sine, and I know I've got the sine squared is 1 squared, so I end up with negative 1, or I get 1 squared over 1 over 1 squared, but it's negative, so I got a negative 1 here. 2 times, well, the cosine is 0, so 0 over 1. This doesn't even matter, but it would be 1 over 1, and that's a big 0. So my slope's just actually negative 1. That's all we've got here. Now, I have a point, I have a slope. So, to write my tangent line equation, I just start with y equals the slope times x minus x sub 1 plus y sub 1. And then I simplify that down. Well, slope-intercept form, the best I get is negative 1 times x is negative x. Negative times negative is a positive pi over 2 plus 2. And I can't combine those, and I don't want to write something irrational. I'd like to preserve the accuracy of my function, so I'm going to leave it right like that. Now to find my normal function equation, I need the perpendicular slope. Well, the opposite reciprocal of negative 1 is a positive 1. So I just, same point, pi over 2, 2. All that's the same. The only thing that changes in writing my normal line is I put in the opposite reciprocal slope. I simplify it just the same, distribute my 1, and in this case, for my normal line, I get x minus pi over 2 plus 2. And that's all there is to it, folks, when you're writing equations of tangent and normal lines. Find the point, plug in your x value to your function, get the y value. Find the slope by taking the derivative, and then evaluating it at the point in question. Now, some of your problems on your homework will be a little more interesting. They'll have numbers that aren't pretty. let's say you're asked to find the equations for lines tangent and normal to the graph of f of x equals tangent of x over x at x equals 2. Well, you know right away that's not going to be a pretty number. You can't write it in terms of sine and cosine. So I'm going to give you the advice of store your irrational numbers in a calculator, round them as the last step. Okay? Now if you do that, you just take this function, tangent of x over x, and all we want is we just want the tangent. We make sure we're in radian mode, okay, and we want the tangent of 2 divided by 2, and there's our number. There's our, and I'm going to just store that as a, and I will remember that that's a, so as I calculate, I got that. Okay, now to find my slope, I take the derivative. Recall, this is a quotient rule thing again. So the bottom times the derivative of the top, so you get secant squared, so derivative of the tangent, minus the top times derivative of the bottom, that's just 1, over the bottom squared. Well, that doesn't really simplify too much. It is what it is. And to find that answer, I'm going to have to do all of that too. Let's see if I can find a way to put it in here. So I'm going to have to put that into my calculator, and I'm going to have to think in terms of 2 times, and the secant is 1 over the cosine. So I'll just do 1 divided by the cosine of 2, and I had to put my double parentheses, minus the tangent of 2, and I need that before I divide it by 2 squared, so divided by 4. So there's my slope